Good morning. We are Team 1 and we are going to be presenting the problem situation, a preventable tragedy, the explosion in Beirut in 2020. The table of contents that we are going to be reviewing today is first of all, the Beirut explosion, then ammonium nitrate, afterwards the compounds, and then toxicity, environment, and to finish our conclusions.
So let's talk about what happened at Beirut. On August 4, 2020, 2,750 tons of improperly stored ammonium nitrate exploded at the Beirut port. This was caused by an unattended warehouse fire. There were two different explosions with 30 seconds in difference. The second one caused supersonic pressure and a massive heat wave. There were a bunch of toxic gases that were released, and there was also a white crater created around the explosion and an earthquake. So let's talk about this ammonium nitrate that we see it's so toxic. What is it? It is a result of the reaction between nitric acid and ammonia, and it is a crystalline solid.
This is a molecular structure of ammonium nitrate that consists of an NH3 ammonia ion plus an HNO3 nitric acid ion that ends up being an ammonium nitrate.
The physical and chemical properties of ammonium nitrate is that it's a crystalline solid. Its molar mass is 80.043 grams per mole. Melting point is at 169.6 Celsius. Boiling point is 210 degrees Celsius. And that is a hygroscopic. This means that it has a great affinity for water, absorbing ambient water vapor.
Polarity, solubility, and density in a healthy state. Ammonium nitrate is a polar molecule that is extremely soluble in water. Displayed on the slide, you can see some of its solubilities at different degrees. The density of ammonium nitrate is of 1,720 kilograms per meter cube or 1.72 grams per centimeter cube at 20 degrees. Compounds involved. Compounds, bonds, geometry, and polarity. Ammonium nitrate consists of two things: the ammonia ion that has a tetrahedron molecular geometry and the nitric acid that has a trigonal planar molecular geometry. Ammonium nitrate is a polar molecule with ionic, polar covalent, and non-polar covalent bonds. The nitrous oxide has a linear molecular geometry, is a polar molecule, and has polar covalent bonds. Water has a bent molecular geometry. It is a polar molecule and has polar covalent bonds. Nitrogen has a linear molecule geometry. It is a non-polar molecule and has non-polar covalent bonds. And to finish, oxygen has a linear molecular geometry. It's a non-polar molecule and has non-polar covalent bonds.
For the intermolecular interactions, we observe that ammonium nitrate and water both have the three intermolecular forces. Nitrous oxide has dipole-dipole and dispersion forces, and for the case of the nitrogen and oxygen molecule, they only have dispersion forces.
The physical and chemical properties of nitrous oxide is that it's a gas. Its molar mass is 44.013 grams per mole. Its boiling point is minus 89.5 Celsius, and it has a gas density of 1,843 grams per milliliter, and its melting point is 89 Celsius. The physical chemical properties for water is its molar mass is 18.053 grams per mole, that it's a liquid. Its melting point is 0 Celsius. Its boiling point is 100 Celsius, and that it reacts with acid oxides, basic oxides, metals, and non-metals. The physical and chemical properties of a nitrogen gas, first of all, it's a gas. Its molar mass it's 14 grams per mole. Its boiling point is minus 194.8 Celsius, and its melting point is minus 209.15 Celsius. And the last one is oxygen. Its molar mass is 15.99 grams per mole. It's a gas also. Its melting point is minus 218.8 Celsius, and its boiling point is 182.96 Celsius. The physical properties of a compound depends mainly on the type of bond that holds the atom of a molecule together. These can indicate the type of structure, and it predicts its physical properties.
So let's discuss the toxicity of these compounds. Ammonium nitrate, we saw it can be very toxic if it is handled incorrectly. Nitrous oxide is very poisonous on the human body, and it also has high global warming effects. Water, of course, it isn't toxic as long as it doesn't intervene with other substances or the actual ecosystem. Nitrogen gas, well, there's 78% of nitrogen in the air, so we can say it is very stable and non-reactive. However, if we have too much nitrogen in the air, we can reduce the oxygen content of it, and that could have big damage on the atmosphere. Oxygen as well, not very toxic. However, if we breathe too much of it, we can get oxygen poisoning. So how can we actually store this ammonium nitrate? This is a perfect example of it. This is Jordan in the Middle East. The reason why this is perfect, it is because it's in the middle of nowhere. It is 70 kilometers away from the city. It is made of concrete and steel so that if one stack blows up, the other ones won't be affected. And also it has heat regulation. So this would be the perfect example of how to store it.
To conclude, we are going to talk about the impacts that this explosion has. As we already know, the explosion leaves large amounts of waste, but not only that, it also leaves contamination of water supplies, waste management affecting populations, soil, water, and potential atmospheric hazards in the area. On the other hand, in the case of the social impact, we have, as we already know, a lots of deaths, injured people, people was displaced, causing migration, and also risks due to the pandemic. Well, other factors that are involved in the explosion. We believe that not only technical factors affect, but also indifference and corruption, especially in the monitoring and implementation of laws and regulations, putting more weight on power than the awareness of what this type of catastrophes can have. That will be all for us. I hope you enjoy it, and well, thank you. This is a bibliography, and that's all.